Example 1 here on group data is taking a look at estimating the mean and standard deviation from a histogram. So here we're simply asked to find the mean and standard deviation of the data in the histogram below. So the first thing we need to do here is create a table of the data from the histogram. So for example, we can see our first class will be between 0 and 3, the next class will be between 3 and 4, the next one after that is 4 and 5, and so on. And we can see the frequency then by using the frequency density to get our frequency. And what we should get here for our table of data will look something like this. So in that case then, we have our table of data from the histogram. The next step here is to add columns for the midpoint of our class column here. We also need then fx and fx squared. So if we do that, we get something that looks like this. Notice x here is our midpoint, this is the midpoint of our class column here, and fx is the frequency times by x, and fx squared is x squared times by the frequency. So now all we need to do is use our formulas that we know to find the mean and standard deviation. So for the mean here, that's simply equal to sigma fx divided by sigma f. Okay, so sigma f. So here sigma fx, that's the total of fx here. Okay, so sigma fx is the total of fx. So that gives us 138.5 divided by sigma f, which is the total of the frequencies, which is 31. So we have 138.5 divided by 31. So 138.5 divided by 31 gives us 4.47 there. Okay, so that gives us the mean. Now we want the standard deviation, so let's just clear this just so we've got enough room here to look at the standard deviation. So for the standard deviation, well, first we need the variance, and once we've worked out the variance, we can just take the square root of the variance to obtain the standard deviation. So for the variance here, this is equal to sigma fx squared all over sigma f, and we minus the mean squared. Okay, so minus mean squared. So in that case, sigma fx squared, that's the total of fx squared, so that's 759.75 divided by sigma f, which is 31, and we minus the mean squared. And remember, for the mean, we got 4.47, so minus 4.47 squared. So if we evaluate this, we get 4.55, so 4.55. But this is the variance, okay, so this is the variance. But we want the standard deviation. That's what we're asked for in the question. So let's work out the standard deviation. Remember, we just take the square root of the variance. So therefore, to work out the standard deviation, we just take the square root of the variance. So that's going to be equal to the square root of 4.55. If we evaluate this on our calculator, we get 2.13 there. Okay, so that gives us our solution to example 1 on grouped data. Example 2 here on group data is taking a look at estimating the median from a histogram. So in this example here, we're asked to find the median of the data in the histogram from the previous example. So using the previous example, we know there's 31 data points. So let's just note that here. So we have 31 data points. Okay. Now, if there's 31 data points, that means the median is going to be 31 over 2 as the data point. So that means the median, so the median here is the 15.5 data point. Let's just note that first. Okay, so 15.5 data point. And we can treat the decimal like it is a whole number position for our estimate. So there's 15 data points in the first 3 blocks. So this falls 0.5 data points into the 4th block. And this said block contains 8 data points and has a width of 1. So calculating this then, we are going to be 1 times 0.5 over 8. If we calculate this, this is equal to 0.0625. So that tells us we are 0.0625 into this block. So it's going to be the 4th block here. And we can see this block starts at 5. So therefore, the median is simply going to be equal to 5 plus this value here. So that's going to be 5 plus 0.0625. 5.0625, which gives us a value of 5.0625 there. Okay, so the median is 5.0625, and that gives us the solution there to example 2 on grouped data.